So in this video, I'm going to be going over how you can graph regression functions using the TI83 and TI84 graphing calculators. I'm going to be using a TI84 plus CE today. And unfortunately, I don't have a TI83 with me today. So if you do have a TI83 or a TI84, I do recommend following along because I am going to be going over some differences that I won't actually be able to show you in this video, unfortunately. But they are subtle differences, but I just don't want to cause any confusion here. So just try your best to follow along. So what is a regression function? So basically, a regression is when you're given basically a set of points, of individual points that you can graph onto a graph. So basically a bunch of ordered pairs. Usually it's in some kind of real life example. And up till this point in your math career, you've probably only done what's called a line of best fit, which is pretty much a straight line that goes through the bulk of the points. And the TI83 and TI84 graphing calculators actually let you do different types of regression functions too, not just straight lines, but you can make quadratic functions and exponential functions and a bunch of other types. So that's a really, really cool function with these calculators that I really like. And yeah, I'll just kind of walk you through it here. The example I'm going to be using for this is basically the growth of a town's population over an 80-year period, I guess. We can also use the function that we find to make some estimations later on as well. So first, you're going to want to get your calculator and start it up. Now, we're going to go to a menu that you probably haven't been before. This is called the Stat menu. You're going to want to hit the Stat button. And the first thing you're going to want to go to is Edit. Okay, so when you go into the Edit screen, depending on who used your calculator last, there might be some numbers in there already. You do want to be in list 1 and list 2. So we'll fill out list 1 first, and then we'll fill out list 2. So if there's already data in there, you're going to want to hit the delete button there. It just says del. And if you just spam that a bunch of times, eventually all those numbers will go away. And you can hit the right arrow to go to L2 and do the same thing. So what we're going to do is we're going to fill in all of these values first and then all of these values. Now, typically you want your X values to be in L1 and your Y values to be in L2. Though there is a way to manually change this. However, I'd recommend just sticking with that. Typically with these types of problems, if you're dealing with time, whether that be years or seconds or any variable of time, you're pretty safe to let that be your X values. Yeah, so anyways, we're going to put in those X values into here. So we're going to stay in L1. And you're just going to input the number. I'm going to move it over a bit there. You're going to input the number and then hit enter. And then that first one shows up. You hit the second number, enter. Third number, enter. And so on. 80. There we go. And you do want your L2 to line up with it as well. You want your points to be matching, otherwise this isn't going to work. So we'll hit the right arrow. Here, let me put this over here. We'll use the right arrow to get to L2. And then we're going to put in our corresponding Y values, okay? And it's always good to double check at the very end. Or check as you're going as well. Because yeah, it's just really easy to make a mistake during this. There we go. Okay, gonna double check everything. We got 10 to 80, yep. And then here we have, yep. Looks like everything is good. Okay, cool, yeah. Always good to double check. So our data is in. That is awesome. Now, from here, I will talk about all those functions I wrote in a second. They're there for a reason. If you want to see your data, actually, I'm going to do that after. I'm going to just do one thing first. So if you go back to the Stat menu, and you want to get a function out of all of your data, go to the Stat menu, and you go over to Calc. You hit the right arrow. Now, you can see there are a lot of different types of functions. Basically, from option 4 onwards is the type of regression functions that you'll want to know. So you have linear regressions, which are basically straight lines, quadratic regressions. There's a bunch of different ones, and it's important to know what at least most of these mean, so you know which option to select. Now, if you're learning how to do this in math class, like if you're doing a unit on exponential functions, for example, like my students currently are as I'm recording this video, you're going to want to use option 0, which is exponential regression. But if you're working through a unit on logs, you might want linear regression, or LN regression. If you're doing something on trig, you might want sinusoidal regression. It's important to familiarize yourself with all of these. And in case you don't know, I'm going to do a quick crash course on just some really basic ones right now. So the first option you see there, that is linear regression. A linear function is just a straight line. Oh, I need to adjust my window. Hang on. I'll go to zoom, option 6 to reset it. So linear regression is just like your typical straight line function. The next option you'd see is a quadratic regression. That's basically a function that's just to the power of, its largest power is 2. This could also be upside down. Likewise, the straight line could also be flipped over. It's important to know the nature of all these functions. This is a cubic function. They have at most 2 turning points. So if your data kind of goes something like that, it's going to be a cubic function. It might be upside down, but the idea is that it has 2 turning points like that. Though cubic functions don't always. It's more complicated than that. This is a quartic function where it has at most 3 turning points. We can't even see the 3rd turning point there. Next up, we have an exponential function. Now, exponential functions can look one of 2 ways. It could be a growth function that looks like that, where it's ascending to infinity. Or you could have a decay function, which starts at infinity and then comes down to a point. Now, it's important to note that you can use option 0, exponential regular, for either growth or decay. So that is a useful thing to know. Couple more here. We have logarithmic functions. Now, the graphing calculator, in terms of giving you a regression function, it doesn't do any logs. It just does ln, so log base e. And that's what your typical logarithmic function looks like. It'll have a vertical asymptote and then go towards a point. And then lastly, we have a sinusoidal function. And I went with this one. So a pattern that repeats, has a clear amplitude, has a clear period, all of that. Right now I have my calculator in radians, so I can do this. And those are the main ones you want to be familiar with. And it's obviously more complicated than that. But again, if you're learning this in math class, you're going to use the option of whatever you guys have been studying. So anyways, let's go back to our data. So we have all of our points in there. Awesome. And if we want to see our points on the graph, we're going to go up to plot 1 and hit enter. Now I hit enter and I see absolutely nothing. And here's why. If you look at our data, our smallest x value is 10, but our largest x value is 80. However, it's the y values that are really screwing this up. Our y values are very, very large. So it makes sense that we can't see them because these are really, really big numbers. So we need to change our window setting in order to see our data. So let's do that. So we're going to go to window. Now, one thing about regression functions, you don't really see negative numbers too often unless you're dealing with like temperatures. So I think we're safe to just make our x min 0 because we're only really dealing with stuff in the in quadrant 1. Alternatively, you could make your x min -1. That's something I like to do, just so I can see the axes as well. And as for your x max, well, 80 is our biggest value. Maybe I'll go to like 85, let's say. Scale, I think 10 would be fine for this. For our y minimum, again, I'll go 0 because we're only dealing with positive numbers here. And as for our y max, well, our largest value there is 2,045. So maybe we'll go to like 250. Oh, that's not 250. Sorry, 2,050 is what I meant to say. There you go. And as for scale, 100 should be fine. Maybe 200 if you want. And if we hit graph, yeah, we can see every single point for the most part here. I can actually probably bring my y min up just a little bit. Maybe we'll go to 2100. There we go. So looking at what we know about functions, I think this is a cubic function. It has 2 clear turning points. It's definitely not linear. It's definitely not exponential. It's definitely not a quadratic. I'm going to say that this is a cubic function. So when I go, actually, I'm going to write this down here. What type of regression function are we working with? This appears to be cubic. Now, if I want to get the equation for this, now that I know what type of function I'm working with, I'm going to go back to stat. I'm going to go to calc, and I'm going to go down to cubic regression. Again, you got to pick the one that really represents the data that you're looking at. If it looks like an exponential function, you'll want that one. If it looks like a logarithmic function, you'll want to use that one. I don't know why there's two options for linear functions. I've played around with this. It's basically the same thing. So I really don't know why that's a thing. Also, the exponential functions don't, you'll see it doesn't have it doesn't offer the option to show you where the horizontal asymptote is. It's just, if you select this, it will literally just tell you the A value and the B value, but it doesn't tell you where a vertical shift has happened. So that's a little bit annoying that it has two of these, but it doesn't have that. Anyways, we're going to select cubic regression. So first you have to tell it what list you want to use from your data to make the X values. Now, luckily, this is the default, so that's nice. If you don't know how to change this, you can see the L buttons are in blue below at the bottom of your calculator. You can just hit second and just manually change it if it was like L3, for example. But we're going to keep it L1, L2. This is the default, and you can always ask your teacher how to do this too if you get stuck. Yeah, okay, so now this is one difference on the TI83 and TI84 plus, so not the one I'm using. You might not even get this menu. And I'm not entirely sure how to reset it if it does get screwed up, but this is the default, so you should be good. And usually at this point, you can just hit enter. If you don't have this screen, you just hit enter, and then it will produce the function. It will do this. And for a cubic function, it's given us the A value, the B value, the C value, and the D value. So basically, you would plug all of those numbers in, and that would be your function. Now, you could just write all of this down and plug it in manually, but if you want to get the graph, another thing you could do, actually, in fact, the question is asking us to write the equation for this. So I think what we'll do, we can write the whole thing, but I think just for the answer, I'm going to just round it. Though you'll see on the next stage here, I'm actually not going to round it. I'm going to use the actual numbers, but we could just plug in our A value, B value, C value, all that. So I will do that really quick. I'll just round to 3 decimal places, especially since our A value is a little bit weird. Plus 99.154x. And our y-intercept is 511.286. There we go. Hopefully I rounded all that correctly. So yeah. Now, if you didn't want to write all of that down and plug it into your graph manually, there is another way you can do this. So if you go to stat, go to calc, and just reset the whole thing, just go down to cubic regression. Again, on the 83s and 84s, this will look a bit different. But at this stage where it says store regular equation, or on the 83s and 84s, it won't even say that. Here's one thing you can do. First of all, make sure your y equals is all clear. Yeah, mine's good. And I'll just go back to that menu again. So again, on the 83s and 84s, you won't get this menu, but it still works the same. Before you hit enter, just go to this button, VARS, scroll over to Y variable, and under function, just select Y1. Right now, what you're doing is you're telling the calculator, hey, so I don't have to write down the whole thing. Can you just plug it into Y equals for me? Thank you very much. And then you hit calculate. You'll get the same function as we got before. But now if you go into Y equals, everything's there already. And nothing's been rounded either, which is great. And if we hit graph, there's our regression function. That is awesome. And now that we have the function, we can actually use this to do some problem solving as well. So let's check out the rest of the problem here. what do you expect the population to be in the year 1990? So you can see that this data is actually years after 1900. So year 1990 would actually be an X value that's after that. And we can use this regression graph to figure that out. Now, if you have an X value and you're looking for a Y value, you're going to use the trace function. So you're going to use trace plus the number, and then you hit enter, and it should tell you the Y value that matches up to it, okay? Now here's one problem, and it's an easy fix. You hit trace, and you hit 90, and your calculator freaks out a bit. You can't use the trace function if your data plot is on. So what you do is just go back to Y equals, go up to plot 1, hit enter just to turn it off, okay? A lot of calculator errors kind of derive from just having your plot on still. So you can always just go to Y equals, scroll up, and turn it off, turn it on, whatever. And now I can use the trace function. Now, one other thing to note too is our window. Right now we don't have 90 visible. So maybe we'll bring our X max up to 100 so we can actually see the X value 90. And now we should be able to use the trace function, no problem. I think trace works even without doing that, but it's best just to extend the domain a little bit there. So trace 90, enter, and there we go. We can see that we have a Y value of 2,980, and I did round down there. So I would expect the population to be that in that year. Finally, in what year is it expected that the town's population will be 3,500? So this is a case where we actually have a Y value and we're looking for an X value. And unfortunately, this isn't quite as simple, though it is pretty simple still. What you need to do is basically create a straight line for that value, a straight horizontal line through the Y value 3,500. So I'm going to go to Y equals, and for Y2, I'm just going to create a straight line at that Y value. Now I can't see it. And the reason why I can't see that is because if we go back to my window, we can see our Y max is actually pretty small in relation to that. So I need to make this larger so I can actually see the straight line. So I've increased my range. And there's the straight line. Cool. In fact, if you want to give yourself a bit more wiggle room, you can actually go a little bit larger than that. Maybe we'll go to 4,000. And what we're going to do from there is we're going to find the intersection point of these two functions. Because if that is a Y value of, just a flat Y value of 3,500, that intersection point will be where the graph, the blue graph also hits 3,500. So what we're going to do is we're going to go to the calc menu, and this is done by going second and then trace. And you're going to select option, I believe it's option 5. Yep, option 5, intersect. And for your right bound and for your left bound and right bound, oh no, sorry, your first curve and second curve, sorry about that. You're gonna wanna get really close to the intersection point. Especially when you're dealing with sinusoidal functions, there might be multiple intersection points, so you really wanna make sure you deal with the one that's in question. So we're gonna get really close to that intersection point on the first curve, really close to it on the second curve. So we're gonna hit enter 3 times, and then we can see when we have a Y value of 3,500, the year is 94.2. So in other words, during the 94th year, the population is expected to be that. So in what year is it expected the town's population will be that? And this is a case where I am going to round down no matter what. 1994, because that is 94 years after 1900. Now, I do have one last thing to say about this function. If you're looking for a peak or a minimum, like a relative maximum or a relative minimum, you can also do these. Some problems do require you to figure that out as well. For example, maybe the question asks you, at what year was the population at its peak before experiencing a drop or something like that? You can use the maximum function in the calculator too, and just kind of isolate a left bound and right bound for that maximum. And you could do it that way as well. So I didn't want to spend too much time on that, but just keep in mind you can use the minimum and maximum function for some of these problem solving. So anyways, this video is long enough as it is, but I hope this helped. Again, the 83s and 84s can be a bit different from the CEs. Just when it comes to this menu, you won't get this menu. You'll just get a little text that says cubic regression, and then you hit enter. And if you do want to store the function, you'll have to do it at that point where you go VARS, VARS, function, and then you can manually input it like that. Yeah, there you go. Anyways, thank you so much for watching, and I hope this helped.